You know Delta Lake gives you ACID transactions and time travel on your data lake. But have you ever wondered how it actually makes that happen on top of simple object storage? Today, we are pulling back the curtain on the transaction log, the write-ahead log, and the magic of metadata, the three pillars that make Delta Lake not just a format, but a full-fledged storage layer. Delta Lake fails without its invisible transaction engine. Let's expose it. But what about all the modifications? The updates, deletes, and merges you run daily. If it is just parquet, those are destructive, permanent actions. That creates unrecoverable chaos. Here's the architectural magic: you never overwrite a file. Instead, you create new versions. But how does the system know which version is correct? That's the entire game. Think of your table as a movie, not a photo. You cannot reconstruct a film from a single frame. The transaction log is that film strip. It is the ordered, immutable story of every change. Without it, you have orphaned data files with no coherent plot. This log is your single source of truth. That log isn't a simple receipt. It's the master controller for the entire system, guaranteeing ACID transactions. Every read and write operation consults it first, establishing serializability across all your jobs. This mechanism delivers the critical atomicity you rely on for pipelines that will not corrupt your data even when they fail. Your Delta Lake pipelines are failing. Three hidden mechanisms are missing. But here's the real question: what happens when your script crashes mid-transaction? How do you guarantee atomic changes with multiple writers? It is that JSON file that tells you exactly which data files are valid at that moment. This log is your contract. Without it, your lake is just a collection of files. So you have got multiple jobs writing at once. How does it know what to read? That transaction log isn't just a record, it is the coordinator. Every single writer must check in and commit here first. It resolves the conflict, stamps the transaction, and broadcasts the new truth. The data files themselves are inert, the log is the brain making every decision. This log is the central authority. Without its permission, no data is valid. A writer doesn't just announce its changes, it must plead its case to the log and receive its verdict. This strict protocol is what gives you atomic commits and protects you from the chaos of simultaneous writes. It's the final, unchallengeable judge. You are doing Delta Lake wrong. Here's what everyone misses. Think of your cloud object store. S3 or ADLS has no file locking. So how do you guarantee atomic commits? Delta leverages atomic renames. Every transaction writes to a temporary directory, then performs a single atomic file rename to finalize. It's a brilliant workaround, turning cloud storage's limitation into a rock-solid foundation for ACID compliance. But here's what they don't tell you: that atomic rename is actually a lie. The cloud has no rename. In reality, it is a single atomic metadata operation on the transaction log file itself. This is the secret weapon. A single, final write to the log, made atomic by the storage system. That's how you get bulletproof commits without locks. Here's the brutal reality of that atomic commit. A distributed cluster writes your data files first, in parallel. Then, a single coordinator makes the final decision. It commits your entire transaction by writing just one tiny JSON file, the final log entry. If that fails, everything before it is just unlinked data. One write to rule them all. That's your true atomic guarantee. Your Delta Lake pipeline? It is probably broken. But that log isn't just a snapshot. It's a living, breathing timeline. Think of it as your data's personal biography. By giving a specific date, you aren't copying the data, you are simply directing the system to read that exact moment from the full history. You are navigating time, not moving files. This is how you audit changes or recover from an error instantly. Now, forget everything you have heard about static data snapshots. That's the old world. In Delta Lake, time travel is live. You don't restore backups, you point your query to a precise moment in your table's biography. The entire history is already there, waiting. Need to audit a bad write from yesterday? Simply query it. Your data isn't just stored, it is alive with its entire past. But here's the critical point, that history isn't just for looking back. You can write forward from it. Fix a critical data error, evolve your schema safely, and all future queries remain perfectly consistent. Every change is a new, immutable version. Your table's state is always valid, governed by the formal rules you define. Delta Lake's magic? It is not the lake, but the delta you are missing. Think about a standard table update. In Delta Lake, that single command triggers a cascade. First, a full scan to locate the rows. Then, it writes new files and meticulously updates the transaction log. This atomic orchestration is why your data stays consistent, but also where that hidden processing tax comes from. Now, look at Optimize. Compaction creates new files for speed, but the log must still track the old, invalid ones. Each remove action is a cost, a performance promise to the future. This is the core trade-off. The log's absolute consistency for integrity demands this overhead. You are managing history itself. This performance tax is silent but real. Every remove logged in your transaction history is an I/O operation your system must forever read and interpret. You are not just managing data, you are carrying the growing weight of its immutable past. This architectural guarantee ensures reliability, but you must architect around its accumulating cost. Your Delta Lake pipeline is broken, and you do not even know it. Your pipeline depends on Delta's hidden ledger. If you bypass it and read files directly, you are seeing a partial, inconsistent snapshot. You will miss the latest data or, worse, introduce corrupt results silently. True reliability comes from respecting the transaction log. It's the single source of truth your queries must obey. Forget tuning engines. Here's the bigger win: every individual write spawns a new log entry and file. A deluge of tiny commits murders performance with massive overhead. You are paying a tax on each transaction. Batch those operations and you slash that cost. This simple discipline is your most powerful lever for speed and stability. Use it. Beyond simple batching, the real architectural insight is in how Delta Lake tracks state. You do not just debug inconsistencies, you can directly rewind or fast-forward your entire table's history. You can query what the data looked like yesterday, before that bad merge. You are no longer just a user, you become an architect in complete control of your data's timeline. Delta Lake's power comes from the transaction log, a journal that provides a consistent view atop mutable storage. ACID transactions are achieved through atomic commits to cloud storage, not traditional locking. Every feature, time travel, schema enforcement, metadata handling flows from reading and writing this central log. Try inspecting the _delta_ log of one of your own tables to see the history of changes for yourself.